Hello everyone out there in YouTube land, Instagram land. I'm not on Twitch, but one day Twitch land as well. This is your lovely host, Key, and you're tuned in to another episode of Build in Public, episode 3 on the Primatif YouTube channel. And if you tuned in for the last episode, then you already know a little bit about what we're making. But if you are unfamiliar, I'm just going to go ahead and start off, and we'll do like a quick little review to get you up to speed. Hey there, it's me. Okay, so before we jump into today's stream, I just want to quickly remind you of what we're working on. So in a previous stream, what we talked about is this comic making application. So if you look here, you can see that we have a comic panel creator, and the purpose of this application is that it allows users to quickly set up the layouts for their comic book pages. And then you can also do collections of pages. Right now the server is turned off, so this doesn't actually work, but you can see here that this is a layout for a comic book page. You can control the gutters, you can make multiple panels. I even have a feature to generate a script using AI, and there's a collections manager which is currently disabled. And so the whole point of this stream is that we are remaking the same application, but this time we are going to be using a different stack of technology. The original application was actually made using React and Express, and for the new application, I'm going to be using Tauri with the SolidJS front end. So just some quick housekeeping before we get started. As you know, this is Primatif. If you want to learn more about the business, the company, and the person behind this YouTube channel, all you got to do is go to primatif.com. And if you go to this website, you can learn more about the services that I have to offer, which include tutoring. I was a professional full stack engineering teacher for 2.5 years, and I currently make myself available for those who want to extend their learning journey with a personal private tutor. And also do consulting work for businesses as well. So more on that later on. I actually have some things to show you in some upcoming streams that will highlight those services a little bit better. So stay tuned. Okay, if you're at this stream today, then more than likely you're interested in learning about Tauri, which is the main framework and toolkit that I'm using to make this application. If you go to the link in the description, you'll find that there is a link to the Tauri guide that I will be going over today. This guide here has all the information that I'm going to talk about, and it also has links that you can go to as well that will convey some important concepts about not just Tauri, but also about SolidJS and some of the other things that we have going on for this project. It's pretty short. There's only really 6 sections here, and this is going to be the basis of today's stream. Now, here's my caveat. I am not a Tauri developer. The whole point of this stream is really just a chance for me to have a beginner's mind and to learn. So I am learning along with you. I have experience with other things, with other programming languages and other frameworks. I've done React Native and a bunch of other stuff locally and for desktop. But Tauri is specifically new for me, so I'm going to be learning along the way. And the primary resource for learning about Tauri, of course, is tauri.app, which is their website, and you can learn firsthand what Tauri is meant to do. Now, the short version is that Tauri is a framework that allows you to have agnostic front end, so your front end can be made pretty much of anything, and then Tauri has the ability to wrap that entire application together as one executable with a Rust backend, and then Tauri itself also runs on Rust as well. In the process of learning about Tauri, something that I found really helpful was actually listening to a podcast. So if you're familiar with the Syntax podcast, they have a YouTube page as well, but there's this episode called Is Tauri the Electron Killer? And if you go to this stream, you'll see that this is the person who is responsible for the creation and the direction of Tauri. I'm not sure exactly what his position is, but this is an excellent podcast. They also have a website which is syntax.fm. Since they are a podcast, and then of course you can find them on your favorite podcast provider. I like to use Apple Podcasts. So this is the specific episode. So 821 is the episode you're looking for. I strongly recommend listening to this podcast because not only does it kind of explain what Tauri is, but also it'll get you up to speed as far as what Tauri can do in the most recent version. Excuse me. Okay, so consider those to be some good resources. As usual, the main first-hand documentation is always the best place to go if you want to have crystal clear information. Today's stream is going to be pretty direct, pretty straightforward. I'm going to have this guide, this one right here, off screen. And actually, you know what? No, we'll just have it right here. Yeah, we'll make this work. I'm going to have the guide right here. Feel free to follow along if you would like to. And we'll make this work today. Okay, so this is the guide for understanding Tauri. Okay, let's go ahead and get started. I'm so excited. Okay, so let's see. Let's go down here. I already showed you the Tauri website. Ooh, excuse me. I already showed you the Tauri website, so we can already go ahead and skip down here. So I'm just going to read through this, and then we'll talk about it as we go. So before we dig into the code, let's get a high-level overview. What exactly is Tauri? At its core, Tauri allows you to build the user interface for your desktop application using familiar web technologies. And in my project, I'm using SolidJS. If you wanted to, you could use React, you could use Vue, you could use vanilla HTML and CSS. It is also possible to use Tauri with other front-end frameworks. Another one that I learned about that you could use with Tauri is called Dioxis. If you, for example, wanted to have your application completely in Rust, then Dioxis could potentially also be a way to create that front end with Tauri. So it is front-end agnostic. And with Tauri, one of the main things here is that it is going to use the web view, the native web view of whatever operating system that the application is running on as its target for displaying that interface. Okay, so if you're on a Mac computer or a Mac device, it's going to use the Mac web view. If you're on a Windows PC, it's going to use the one that corresponds to Windows, and same thing for Android, and same thing for Linux. All these operating systems have web views. One of the best ways to understand like what exactly the web view is in your application, in fact, is let's say that you're on the Instagram app, and on Instagram, a user can actually have a link in their profile. When you click that link and it opens up a browser that's not your normal browser, that is the web view. Okay, so that's just an example of what that is. Now, what makes this really cool is that with Tauri, since it is targeting the web view of the device and the operating system, that means that your application can more easily run across different platforms. So, whether it's a Mac computer or a Windows computer, as long as the front end is capable of rendering in the web view, then your application can essentially run. And across the board, for the most part, as long as your operating system and the web view is up to date with the latest version, which generally it is, then you're going to have a consistent experience across those different platforms as well. Okay, so this really solves a huge problem with the ability to target multiple platforms when you're making an application. You can build it once and deploy to a variety of different environments and contexts. So I think that's pretty much the most important thing for that. If you're like in the web development world, you probably know a little bit about React Native. React Native is the OG. That's pretty much how I got my start, working on more native or desktop style applications. Well, for me, it was more native applications. Similar-ish concept, okay? Similar-ish. The more popular one that people use is actually called Electron. Electron is probably the more popular. I feel like I once heard that VS Code was like an Electron app. I don't know. But Electron is like the most popular because it is all JavaScript, front end, back end, and also for the toolkit. And this allows you to package your application as a desktop application as well. Now, the benefit of using Tauri over Electron is that Tauri is just more performant. It's more performant because it's written in Rust, okay? And so the back end and also the tooling around it, that's all Rust. And Rust is extremely fast. It's a very low level language. It's up there with C in terms of its speed. Now, that's just one part. The other part is that when you're working on a Tauri application, the size of the actual application is significantly smaller. And that actually, if you listen to that podcast that I mentioned at the beginning of the episode, one thing that is mentioned in the podcast is that the size of your actual release becomes really significant at scale. Now, this isn't directly going to cause performance issues for the user. Well, it can, but the most important thing is that when you have a really large package size, you're the one, or your customer is the one paying for that premium of being able to store and to download, transmit that file, or those updates for the application. So by keeping it really, really small, it's more cost effective, it's faster, and it's less resource intensive. And that also translates into being more eco-friendly as well. Okay, so Electron's the major competitor. When you search on YouTube for information about Tauri, what you will likely find are mostly videos at the top of your search results that are comparing Tauri to Electron. Electron, just to be honest, is a lot more of a mature ecosystem, meaning that it's been around longer, there's a lot more robust tools that are available for it, but Tauri solves such incredibly important problems that it's growing at a really fast rate, and it also has some really good support as well. Okay, so so that's pretty much that. Rust-powered backend. This is where Tauri truly shines. The backend logic, the engine of your application is written in Rust. Rust is a modern programming language known for its incredible performance, memory safety, and reliability. This means your application will be fast, efficient, and secure by default. One thing to note here is that Rust is a compiled language. Okay, so when we're doing this Rust development, we're going to make sure that it compiles correctly, and it needs to in order for the application to actually be built and ran. And that's different from the process of working with JavaScript. When you work with JavaScript, there's no compiling. When you work with TypeScript, it is transpiling into JavaScript so it can run in the V8 engine, but there's no compiling, so to speak. And that's going to be a pretty significant difference if you're not used to developing in Rust. Another thing that's different in Rust in comparison to strict JavaScript is that Rust is very intense in terms of your typing, and also because you're responsible for managing the memory. That's also, a pretty significant part of the Rust development cycle as well. Okay, so Tauri is designed with security as a top priority. It has a comprehensive security model that, among other things, prevents your application from making unexpected requests or running unauthorized code on your machine. So one thing about Tauri that is interesting and is talked about in that podcast is that when you have an application that's targeting like desktop or even mobile devices, which 2.0 I think 2.0 actually does target mobile devices. There's always like this step of asking for express permission from the user in order to do certain things, such as read the file system. And then there are other things that are included. For example, have you ever downloaded an application on your computer and then it doesn't open and you have to go to the privacy settings or the security settings in order to approve it if it's not downloaded from the App Store? Well, that's an important thing. And there are other security things that are on par with that are super technical, but really, really important, and Tauri has your back. One of the big things is that Tauri also, since this is a desktop application, also has the ability for your applications to be signed, and it also has built-in support for automatic updates, over-the-air automatic updates as well. And those are, some pretty significant security, security areas to consider. I'm not going to go too deep into that because it's not my area of expertise, but just from based on what I know, listening to the podcast and also doing some quick research, it seems like just building with Tauri, you're already getting a lot of security things included with that as well. And then I already mentioned the tiny bundle size. Because it leverages the operating system's data view, it doesn't need to bundle a full browser like some other frameworks. And when it says other frameworks, I think it's talking about Electron here. So yes, so the bundle sizes are extremely small. I think they said that the smallest app they ever built with Tauri was like in the kilobytes, which is just incredible. Okay, so yes, so every operating system has its own native web view. Mac OS uses WebKit, Windows uses WebView 2. I'm not sure what Linux uses, but they're all comparable. They all essentially are doing the same thing. I think there are probably some minor differences, but for what we're working on, those differences are not going to be that significant. Okay, so that link did not work. Let's just go ahead and move forward. I will check these links and try to get them fixed up if they're broken. Okay, so that's just like the Tauri part. Now, as I mentioned, Tauri is agnostic in terms of the front end that you can use. For this application, I elected to use SolidJS. SolidJS is a reactive JavaScript library for front-end development. And if you're coming from the world of React development, the major difference here is that in React land, whenever your front end is reacting to a change in the state, so remember your event state render loop, whenever the front end changes that state, React actually compares the DOM to a virtual DOM. And the larger the data structures and the more complex your DOM is, the slower that becomes. And with SolidJS, it removes that virtual DOM part of things and just directly allows the DOM to be manipulated as the state changes. And so that gives a pretty significant boost to performance. And it makes for a much simpler model of state management and DOM updates in general. Okay, so it's just more direct. Feel free to go to their website and read through it. As far as the actual code on the inside, there are a lot of things here that are just pretty similar to React. So if you're coming from React land, this isn't going to be like, that strange, but it is worth taking some time to look at the examples and to research a little bit. Okay, so let's see what else here. I'm just going to read through this. So before we tour the project structure, let's talk about the specific front-end framework used here, which is SolidJS. And I already mentioned the React virtual DOM. When the state changes in a React application, React re-renders the entire component and its children. It then creates a virtual representation of the UI and compares it to the actual DOM to figure out what changed. This comparison process is how React efficiently updates the screen. So with SolidJS, there's fine-grained reactivity as opposed to a virtual DOM. SolidJS takes a completely different approach. It does not use a virtual DOM. Instead, it uses a system of signals and effects. Signals and effects, and those are the two hooks that you'll see later on here. When you update a piece of state, which is a signal. SolidJS knows exactly which parts of the DOM depend on it and updates them directly. It doesn't re-render the whole component, which leads to exceptional performance. Okay, so in comparison to vanilla JavaScript, with vanilla JavaScript, you would have complete control. If you've ever gone through a boot camp or anything like that, you know that in vanilla JavaScript, you're responsible for your selectors, you're responsible for reading the DOM, you're responsible for injecting things into the DOM, you're responsible for all of that. There is no, there's no state management loop, so to speak, unless you create it. So you manually find DOM elements and update their properties, get element by ID, get element by class, that kind of thing. This is the most performant way to do things, but it can become very complicated and hard to manage. I would be very, very, very sorry for the person who had to make a full-on single-page application using vanilla JavaScript. It could be extremely fast, but it would be really annoying to develop. So JavaScript or SolidJS gives the best of both worlds. With SolidJS, you can write code that looks declarative and component-based like React, but the compiler turns it into highly optimized JavaScript. So what this is saying is that you're going to write some code in SolidJS, but then that is going to be, I think the better term to use probably is transpiled, but we'll let it live. It's going to be transpiled into very efficient JavaScript, essentially, that updates the DOM directly. So it's like writing clean, modern code that performs almost as fast as that vanilla JavaScript. So, yep, so there's a website. Go check that out if you get a chance. And I guess the 2 points here to know are that there are these 2 primary hooks that will be used. Let's just take a quick look at what this has to say. So basic reactivity. Solid's overall approach to reactivity is to wrap any reactive computation in a function and rerun that function when its dependencies update. And the Solid JSX compiler also wraps most JSX expressions, code embraces, with the function. So they automatically update and trigger corresponding DOM updates when their dependencies change. So more precisely, automatic rerunning of a function happens whenever the function gets called in a tracking scope. So here's just an example. I don't think this is super helpful if you're a beginner, but this is what it is. Now the 2 parts here that matter are the create the signal and the create, what's the other one? So we got create signal and create effect. So that's funny. This is all on the same page, but I have 3 tabs open. Let's just scroll down. Okay, so create signal. Signals are the most basic reactive primitive. They track a single value, which can be any JavaScript object that changes over time. The signal's value starts out equal to the passed first argument, or the initial value, which is undefined if there's no value. And then the create signal returns a pair of functions as 2-element array, a getter for accessing and a setter. And this is actually pretty much the same as Redux. If you use Redux, or if you actually, better example, let's just go over to the React state page. I think this is it right here. Okay, so in React, you have use state. So create signal with SolidJS is essentially doing something very similar, at least on the surface, to use state. When you use state with React, it's 2 functions that come in an array that you deconstruct. And the first one is for accessing, and then the second one is for setting. So it's a getter and a setter. That's essentially what is happening here with SolidJS. That's what this is saying here for create signal. So you can see here, same thing, boom and boom. So when you call the getter, it returns the current value of the signal. And then when you call the setter, then you call it as a function in which you pass a new value that becomes the updated value. Okay, so here's an example here. And what's important here is that if you have a variable that you need to update on the DOM or something on the DOM that needs to be reactive, it needs to be a signal as opposed to just a, a let or a const, or probably a let variable. If it's a signal, that means it's going to be picked up by SolidJS and update the DOM. If it's just a variable, it's not going to change on the DOM. Okay, so the last part is create effect. Effects are a general way to make arbitrary code run whenever dependencies change. To modify the DOM manually. So create effect creates a new computation that runs the given function in a tracking scope, thus automatically tracking its dependencies and automatically reruns the function whenever the dependencies update. Okay, so I think that there's actually a good example of this as well. I'm pretty sure that it is conceptually similar. Yeah, it's conceptually similar to what useEffect is doing in React. So in React, when you use useEffect hook, then there's two arguments that you provide it. So the first one is you provide it something to do, which is like an arrow function or something like that. And then you give it a dependency array. This dependency array is basically things that are looked at to monitor. And if those things change, such as a variable or even another piece of state potentially, if those things change, it will recall whatever that setup step was. Okay, so it'll do it once when the page loads, and then it'll do it again every time something in the dependency array changes. And that essentially is kind of what create effect is doing here as well. So there's some direct parallels here, although the underlying stuff that's happening is likely very different. Hence, SolidJS is using a different underlying model for how it's working with the DOM. Okay, so the effect function gets called with an argument equal to the value returned from the effects function's last execution, or the first call equal to the optional second argument create effect. This allows you to compute diffs without creating additional closure to remember the last computed value. So for example, this right here. Now, I don't fully understand all of this. Let's see here. A plus B. If sum is previous. Okay. I think what this is saying here is that when you use create effect, this variable here previous, it's going to be whatever the value was that was returned in the last time create effect was called. And you can bring that in as a argument in the next iteration, essentially. So effects are meant primarily for side effects that read but don't write to the reactive system. Okay. It's best to avoid setting signals in effects. Okay. Okay, so that is definitely, setting signal or setting a state inside of a use effect in React is also dangerous because you can run into some like infinite loops and stuff. Yeah, so it's kind of the same thing here. Use create memo to compute new values that depend on other reactive values, so the reactive system knows what depends on what and can optimize accordingly. Okay, so this is an important detail right here. The first execution of the effect function is not immediate. It's scheduled to run after the current rendering phase, after calling the function pass to render, create root, or run with owner. If you want to wait for the first execution to occur, use queue microtask, which runs before the browser renders the DOM. So what this is saying here is that there's like this order, this process that happens whenever your DOM or your page for your application loads, and this create effect it actually occurs within a very specific place in that order. So it is not going to be the first thing that happens. It's going to happen after the DOM loads, and then if there are side effects, those side effects will happen after that. Okay, so this delayed first execution is useful because it means the effect defined in a component scope runs after the JSX returned by the component gets added to the DOM. Okay, so let's check out this really quick. We won't go into create resource and create memo yet, but we will revisit that when the time comes. Okay, so that's a little bit of look at SolidJS. I am not an expert on SolidJS. I've done research and to learn about it. I have always been more of a React developer or just like a straight up Golang developer. But you know, this is a chance for me to branch out and to explore a little bit. Okay, so my intention for this stream is that I wanted to take a look at the actual application code, and then we can take a tour of what's going on in here, and some questions might come up, and that might be a chance for us to do some additional research. Now, I want to just also let you know that this is important to do when you're working on an application. Even if you're working on something that is vibe coded or meant to be just for fun, I always recommend that you take time to actually investigate, like, what is your app doing? You know, this is important because if you make all this code and you don't know what's going on, eventually you're going to run into something that AI cannot fix. And also it could be a very, very, very like challenging issue or something that doesn't work where you can't necessarily go directly find resources or help. I mean, that's just the nature of coding. Lots of situations when you're coding where there's like a very unique thing for your application that's just not working. And if you don't know how to read the code or you don't know how that code is interconnected, you're going to be lost, okay? So let's go ahead and get this app running. So npm run, I think I need to do npm, I'm sorry, we use bun now. We're bunsters. Bun run dev. I think that's the code that we were going to use. And we just have like a basic placeholder app, and we're just going to inspect it and see what it's doing. It compiles the application before it runs. So running it in development mode takes a moment, but this also has hot reloading, so you don't have to do this every single time. And thank you all for joining me today. If you're new to the stream, welcome. Let me get my big head out the way. There we go. Okay, so there's our application. Now what's interesting is that by default, this application is running in dark mode because my computer's in dark mode. It also will run in light mode during the daytime. Okay, so if you right click here, you can click inspect element, and now you can actually go look at the console. The console down here, which is where you'll see information from your DOM, as far as like network, the actual elements, all that kind of stuff. So this is similar to web development. And now we can kind of play around with this a little bit more. Okay. You can actually type in here, and this will give you a message. Okay, so let's go ahead and start our tour. Our tour of Tauri, our Tauri tour. Okay, so for our project structure, there is a basic way that this is organized. Let's just start off by looking at the directory here. I think that's good. Okay, so my project actually has a couple of things going on here. This Gemini folder here is primarily for storing context files So this Gemini folder here is for storing files that provide something for the context, because I'm using Gemini CLI to help build this. Okay, VS Code, obviously contains some workspace settings for VS Code, docs. In my project, I'm using documentation that I create to help with guiding AI to build this. The public folder here contains just some static assets, similar to the public folder that you would have like in a JavaScript application. The source here, this is all of my my front end my front end code. So if you see here, this should look familiar. Welcome to Tauri plus Solid. Welcome to Tauri plus Solid. So pretty much anything when it comes to components and front end logic is going to go into this source folder. Okay, and it can have its own assets, of course, as well. And then the next thing we have here is the Tauri source. Excuse me, I'm just having some allergies today. In this Tauri source, you can see that there's a couple things going on here. So one is that this source folder, this is going to basically be our server. Now, we're not going to communicate to this server necessarily by using HTTP, because remember, this is all being bundled into one application that sort of lives together. So we're not going to have to communicate, necessarily using HTTP per se, but this will effectively act as our server, and we're going to be communicating to this Tauri source code in order to execute things for our front end. So for example, database transactions. We'll also be using it for data manipulation, because Tauri is just much faster than TypeScript and JavaScript. For complex things, we're going to just be trying to use as much of this Tauri backend as possible to take advantage of the speed and performance. And so all of that kind of stuff is going to be found in source Tauri. Okay, and then this is the main entry point here. So kind of like when we're working with like React or Solid, there's usually an entry point file that everything else like sort of bubbles from. That's what's happening here as well. Okay, so we won't look at that right now. Let's see what else is going on here. Because this is running with Rust, Rust has its own things. So Rust uses crates and cargo and all that kind of stuff to manage its own dependencies. So that's what you're seeing right here. You don't have to set up this stuff manually. If you go to the Tauri website and you follow the guide, whenever you get ready to set up your project, there's actually some templates you can use. I just used the template for SolidJS and I kept it easy. Okay. In fact, let me go ahead and pull that up for you. Okay, so here it is right here. So on the Tauri website, they give you, there's actually an NPM script that you can use to create the Tauri app. Well, we're using Bun, so this would be the script you use right here. But you could also use these other ones as well. If you're a PowerShell user, if you want to use Bash, I don't know what Fish is, but NPM, PNPM, any of these will work. I just use Bun because I'm a Bunster. Okay. And when you run that script, you have two options. You can do it by going through like the step-by-step process to set it up, or you can pass in the parameters that completely describe your setup. So the steps here are that you got to define your project name and give it a unique identifier. Then you will just basically select the language of your front end, which you would have the ability to use Rust, JavaScript, TypeScript. I guess .NET is also an option. I've never done front end with .NET, but it's an option. And then for your package manager, so I've selected Bun here. Actually, let me just check my Tauri config to make sure. Yeah, I have it set for Bun. Initially, it was set for NPM, and I changed it. So So you have it, choose your package manager. And then for Rust, if you're using Rust for the UI, there's some options here. We're not doing that, so we just use the SolidJS UI template. And this set up, pretty much the whole front end, placeholder app for me. So that made it really, really easy to get started. Okay, so yep, so that's pretty much that. When we're using this, we're using Vite to build our front end as well, and that pretty much was just an option that I selected when I started my app up as well. So Vite is what I know, but you could use Next.js or something else if you prefer. Okay, so that's pretty much that, and yeah, we can continue forward. Okay, so index.html here, this is like the actual thing that your application is all being, I guess this is considered to be the main entry point for the whole application UI. So the way to think about this is that since this is working in WebView technically only understands HTML, CSS, and JavaScript. That's just a part of the engine. That's what it expects. But this index.html file, that's what you're really seeing here. Now, the reason why we're not seeing this other stuff here is because if you go right here, you can see that there's an index.tsx. And what this index.tsx is doing is it's targeting the DOM, and it's targeting the root of the DOM, and it's saying, hey, what I want you to do is just actually display the app that we're making in this div, which right here is called root. Okay, so this is the thing that is basically acting as a container for the real one-page, single-page app that we're working with, which is actually just this design right here. So this is a pretty typical pattern for web development. You'll see this a lot. As I mentioned, this source folder is where our SolidJS code will live. The package.json, this is going to this file manages our front-end dependencies, and it also defines the scripts for running and building the application. So the scripts are here. These two will start the front end just by itself. You can actually run the front end in your browser if you still wanted to. These scripts right here for Tauri, such as that one and this one, these are to run the actual Tauri application. And then we also have some formatting and linting stuff that I added in the last stream here. And then, of course, if you're new to web development, these are the dependencies, basically other people's code that we leverage to make our life easier. And then we're using Vite to handle, it's basically our build tool. So Vite has its own configuration file. What it will do is it will also allow us to determine the port number for our application. It will also help us control the communication between the front end and any server that we might be coupling with it. We won't have to touch this too much. It pretty much has already been set up for us to work with Tauri. As you can see here, it's passing in some environment variables for Tauri, which are defined in this file here. Wait, let's see. Actually, we don't have a Tauri dev host defined right now. I don't think that might be needed later on. I don't really know about that at the moment. That might be needed later on. But yeah, so this is just basic configurations. Like I said, I did not write any of this. This is stuff that came with the template that I selected for Vite in SolidJS. Okay, so what is a build tool? A build tool is a pretty easy concept. Basically, when we're writing this code here for Tauri, this is not valid for a browser or a web view. Okay, so if you just take a look at this code here, this looks more like a mix of JavaScript and HTML, like if you're looking at this very literally. The browser or the web view does not understand any of this. And so in order for this to be able to work, we have to do something that allows this to be intelligible by the actual browser that we're using. And so what this actually will be doing is when this application runs, Vite is going to be responsible for taking this source code and making it into something that will actually run in our browser. So let me clear this real quick and maybe we can take a look. Oh, I need a new terminal. Let's open up a new one. There we go. And we'll go down to our package JSON, and we can use npm, or let's use bun run start. I'm sorry, bun run build. Okay, so if we look here, we made a new dist folder because we just built our actual distribution. So this is what Vite is doing for us essentially. Vite is taking this really complicated JSX code that we wrote, and it is converting it into this monstrosity here. Okay, so you can even look and see how this works here. This is the thing that we're looking at here. So your browser or your web view is actually running this stuff in the dist folder and not the literal code that you're writing whenever you're working with JSX files. And Vite is the thing that's necessary for doing that. Now, Vite can do other things too. Sometimes in the build process, you might have some type of middleware, or in the case of working with TypeScript, you might need to convert from TypeScript into JavaScript. You know, I don't know if you've ever worked with like Webpack, you know that it could get real deep and also really frustrating. But Vite essentially is kind of in that same space. Okay, so just think about it as a build tool. It allows us to manage the whole situation where we're writing in a way that doesn't work for the browser, but then it's going to do that heavy lifting for us. Okay, so now we can move on to taking a deeper look at the Tauri backend. So we'll go to source Tauri here. And the first thing we'll look at is we have this cargo toml file. Does anyone know what toml stands for? TOML stands for Tom's Obvious Minimum Language. So this TOML extension is specifically for files that are meant to be for configuration purposes. Think of it kind of like YAML. Okay, think of it like YAML. Think of it like the way that we use JSON. You know, it's in that wheelhouse. So the purpose of this is to basically contain configurations, which are oftentimes key value pairs, and which may also be separated into distinct sections or groups. And so that's what we're seeing here. And these are all the configurations that are essentially for the Rust part of our application. Okay, so Cargo is the package manager for Rust, kind of like Bun or NPM would be for JavaScript. And this file here is kind of equivalent to the package JSON file. So you can see here that we have the name of our application. We have dependencies right here. And that's kind of similar to how we have our application name here and the dependencies in our package JSON. Okay, so this is for Rust. And if we go to source, this is the main folder where we'll be having our source code. We have two files here. We have lib.rust and main.rust. These are our main Rust source files that we'll build on to define our application's core logic. Everything we do is going to be somehow connected with these two files. And then we have the build.rs, which is this one right here. And this is the build script that Tauri uses to handle parts of the build process. At the moment, it's very straightforward. We're just building. There's no fancy stuff. I imagine that as we continue to make this application do real cool and magical things, that we will see this, this build file expand. So when you're thinking about building specifically, so building, which is like making the application so that it can be processed, so it can be packaged, so that it can be ran, we're dealing with two main files. For Rust and the Tauri backend, we're doing build.rs. And then for the front end, that's going to be handled by Vite. Okay, so we have two things that are building, Vite, but also we have this Tauri build process. Okay. And this lock file here, this is similar to how Bun, which is our package manager, has its own lock file. Lock files are really important because when you're working with dependencies, dependencies also have their own dependencies. And you don't really want to start duplicating things that are needed between different dependencies. And so these lock files basically are a strategy for your computer to organize the network of these dependencies like a dependency graph in order to make a more efficient use of those dependencies so you don't have duplicates everywhere, which ultimately saves in terms of memory and speed. So the cargo lock here, this is generated when your application builds. In fact, this could be included in your git ignore. It's debatable. Some people keep lock files, some people ignore them. I'm not going to ignore mine. But if you're working on a team, sometimes it can be annoying. But we're gonna leave it as it is, okay? So let's see here. Yeah. To learn more about the Tauri crate, you can actually go to crates.io. Crates.io is the main website for the Rust crate registry. This is similar to NPM, which is the main registry for NPM, Node Package Manager. Now, Bun will access, not those buns, sorry. So Bun will essentially leverage the NPM registry, but Crate and Rust has their own registry here. And there is a specific crate for Tauri. And if you come here, you can read this. This is primary information here. So we've already been over this, so we don't need to talk about this again. I lost my webpage. Give me just 1 second, 1 segundo. Okay, we're back on track. Okay, so that is Tauri. There's also a Tauri config reference as well. The configuration references are nice because when you're dealing with just the template that you get, you may not necessarily be aware of like all of what your future options are going to be, or like what you're going to need in the future. And you know, with AI and stuff, you're gonna have like a lot of help with this. But one of the main things is that this configuration is going to influence a lot of things, not necessarily like in the way your app looks and feels for the user, but in the context of the environment and in the bigger picture, this is really important. So if we go to our configuration file right here, you can see that Tauri config, in comparison to like the node package.json or the cargo.toml, this Tauri config, this isn't specific to like Rust or JavaScript. This is about the application as a whole. Okay, so just remember, there's really 3 parts here. Actually, we have a diagram that we can look at. Let's look at this diagram here. Okay, so we have this application as a whole. Tauri itself is basically responsible for containing the whole of our application. And within Tauri, we have a Rust server, and we also have a JavaScript, a SolidJS front end. This Tauri thing that's over all these other parts of our stack, that is what this Tauri config.json is for defining. And so when it comes to, for example, what is the size of our window when our application first runs? Well, we can say 800 by 600 here. Okay. What is the name of our application at the top? So you see up here where my mouse is, that name comes from line 15. Okay. And we can do a whole bunch of other stuff as well. But that Tauri config page, that's where you're going to learn what all this means. this build process, this is important here. When our application runs, we want to make sure the front end is running first. Then we want to make sure that there is a URL that we can use to display in our application. And then we want to make sure that we run a build. Okay, and that build is going to result in a front end distribution. Okay, so development, and then this is the final build. Okay, excuse me. Now each of these has their own versions. Versioning is complicated, it's weird. Your front end and your back end, they're going to have versions that change independent of one another. Typically, you might have a team of people working in either part of the application, and they will just version as they go and target, the front end or the back end for specific versions. And then you're gonna have a version for the app as a whole. And all this has to be managed in some way. We don't have a system for that yet, but we will have to develop a solution for that as we move towards production with this application. Okay, so I think that's pretty much it. If you're tuned in to this stream, I just want to say thank you for coming by. Go ahead and leave a comment. Let me know if any of this is new for you, what you find interesting, or if you have any questions. I would love to incorporate those questions into the next stream, and I would love to hear from you. So don't be shy. Get on down in the comments and let's get the conversation poppin'. Okay. So let's take a quick break. We'll come back in about 10 minutes. And when we come back, we're going to talk about how the front end communicates with the back end. And to me, that's the most interesting part because like I said before, when we're using Tauri, we're not making typical HTTP requests directly. So like we're not going to be using Axios or Fetch per se, but there's going to be a way that we can do this using what's called invocation. For all you wizards out there, we're going to be invoking the back end, and that's a pretty neat process. So go ahead and grab a snack. If you need to get a beverage, it's late, go ahead and get you, something to drink or whatever, and we'll come back in about 10 minutes and I'll see you right here. Don't go too far, but if you go anywhere, make sure you come on back to Wolfpack and I'll be right here where I'm at. See you in a bit.
model has cleared the tower. Every 4 computers now have primary control of critical vehicle functions.
Welcome back. Welcome back to the back. I'm here. It's your lovely host, Key, and you were tuned in to episode 3 of Build in Public. And if you're new to the stream, then you know that we are working on some really cool stuff over here. And the project that we're working on is making a comic panel application. And this specific stream is dedicated to diving into the actual tools that we're using so that we can better understand them. And this is a really important thing to do anytime you're developing, but most importantly, when you're working with new tools, frameworks, and techniques. So this whole episode is just dedicated to diving into the ins and outs of being a Tauri developer, which is new for me. I am an experienced developer. I've been developing for, since 2018 as a professional. Excuse me. And, one of the things I really enjoy is jumping around a lot. But in an age where vibe coding has sort of taken the center stage for a lot of people, if you go on Reddit, that's all you see people talking about is vibe coding right now. It's really important to make sure you have a firm grasp of what you're doing, so that you're not sloppily just making things that you don't understand. That's great and fine to do. I don't judge it if that's your path as a developer. But our goal in this particular stream, in particular, is to make applications that are production ready and that are high quality. And in order to do that, we really need to be concerned with the exact details of our application and not to leave any of that up for granted, because that can have huge implications once our application begins to scale and once our user base begins to scale as well. So do these things correctly the first time, and you're going to save yourself a lot of heartache, because making software that is meant for customers, that involves a financial transaction, or that has very critical infrastructure, that's a huge risk if you don't do it the correct way. So that all begins with educating yourself and knowing what you're doing. So just before we left, we were looking at the source folders for the front end and the back end. We also took a quick look at the Tauri configuration file here. And now what we're going to do is we're going to talk about really briefly how the front end and the back end communicate with each other through what's called invocation. So let's go over to our browser and go to the Tauri website and find invoke and see if that comes up. Let's just Google it. Sometimes it's easier to Google or to DuckDuckGo something. Tauri invoke, and that is a function. Okay, so calling Rust from the front end. Tauri provides a simple, powerful command system for calling Rust functions from your web app, which is for us the front end. Commands can accept arguments and return values. They can also return errors and be asynchronous. So basically what this means is that our front end is made with JavaScript, right? And typically with an application, there's this concept of the full stack. I think I actually have a graphic right here that describes the full stack. So this is a typical application. Don't mind what this application is, but just look at the diagram and what it explains. So this is a typical way to think about full stack, right? You have your computer, and your computer has an interface, which is typically the web browser. And with this web browser, your web browser can display things on the DOM, right? So the things that your browser displays on the DOM, they can be data, they can be assets like images, and all these things can potentially live elsewhere, somewhere other than where your static application lives. And so what we oftentimes have to do is leverage a server, an API server. Now these servers can be built by us, and they can be built by other people, but essentially they are a different part of the infrastructure that we have to be able to connect with in order to get non-static assets, okay? So that could be in the cloud, that can be on someone else's computer. Even if you have a server locally on your computer with your front-end application, it's still a separate piece of infrastructure that is communicated through a port. Okay, so this is the typical way that works. That's what this illustration shows you here. There is a request that is sent to the server, and then there is a response which comes back from the server, which can be JSON, but it can also include other things like serialized data. Okay, and there are different types of requests. There's actually 4 different methods that we'll be concerned with, but there's even more request methods than these 4. But those are post, get, update, and delete. Now, this is important to understand in general for web development, especially when you have the view model controller pattern of your application. Now, what makes Tauri different is that Tauri is an application that can, in fact, communicate with third-party APIs, but as far as the server that we're building for our application, it is meant to be tightly packed and connected to our front end. And so we actually will not be using HTTP, or we won't be using a REST per se to communicate with that backend. We'll be using functions that we have access to as dependencies in our front end. And so that's what these Tauri commands are. So instead of doing fetch to localhost 8080 or whatever to do a GET request, we'll just be using a Tauri invoke command that will directly go to our running instance of the server and directly manipulate it. And that will make things a lot faster. What this really kind of means, and we'll make a new diagram for this, but let me show you why this is really cool and why this is also really important. So typically, if we have some code that's written in JavaScript, let's make this bigger. I feel like JavaScript is blue. No, JavaScript is green. And then we have another language like Python. And Python is for sure going to be yellow. Right? I feel like Python's always yellow in my mind. And then we have another language like Go, which is my favorite language. I always call it Golang to distinguish it from the board game. And Go is blue. And then we have another language like Rust. Rust is red. Rust is I think Rust deserves its own special color. Rust is like a deep rusty rust. Yeah, like that. Something like that. Okay, so normally when you have an application, applications are composed of many different files that get compiled into, if you're working with a low-level language like Golang, then your Golang code can be distributed between files, but the compiler will work to basically condense it down into a binary that basically merges all of this code. That's a very simple way of putting it. But really just think about the idea that between your different Golang files, you're allowed to declare modules and call code that is in other files from within a file, right? So that's how you get this really interesting way of organizing your file system. And then you can even have different concerns within these files, but they can still leverage each other's code. And that's how we get this whole system of packages and modules and all that kind of stuff, okay? So with this code, we can do this in pretty much any of these languages. They all have their own systems and underlying mechanisms for how this works. And what this results in is that there's typically an entry point file, and this entry point file is what will start the application, and then any of the individual files within the application can relate to one another as they work their way into whatever the logic of the entry point file is. So this is going to be pretty much a similar-ish thing between all these different languages, and I think that is fairly simple to understand. I'm not going to draw all these little connectors here, but let me just do the one for JavaScript at least. Okay, so it doesn't really matter where these lines are going. The main thing here is just know that your files can be interconnected in all sorts of ways. You can borrow functions from one file, run them in another, that sort of thing. Now, when you're dealing with a difference in infrastructure, let's say that we have a server versus a front end. We'll say this is front end, and let's make that a little bit smaller. And then we have a back end right here. So when you have this back end for JavaScript, if you have a mono repo, then you have the ability to still leverage code that is written in your front end, because all you really have to do is just provide a file path, and then as the code is being transpiled, you can it can actually leverage code that's from the front end because they're in the same language, and as long as they're in a mono repo where the build process accommodates for that bridge. It's JavaScript running JavaScript. It doesn't matter where it's from. This is the reason why people like to develop in one language, because you can do things like sharing types, for example. Or if you have utility functions or constants, you can share them between the different parts of your application's infrastructure. Now, the thing is, what happens when you have a back end between two different languages that are not the same? So in this instance, let's say that this back end here is actually made with Rust instead. Let me make a separate one here. Let's just do this. We don't need Python. We'll just get rid of that for now. So let's say we have this JavaScript front end, and we are working with a Rust back end instead. Now the trade-off is that, at least traditionally, we can no longer leverage code directly from JavaScript in our Rust, and we cannot also leverage directly code from our Rust in our JavaScript, meaning we don't have the ability to import a function between two languages and just run it directly, okay? So if I have a function called, let's make a representation of a function here. Let's make our functions into, this is fine. So let's say we have a function, and this one's called get, let's get number. Okay, and let's make this function great. So there's a function inside of our Rust code called get number. If I had another Rust file, I could do the equivalent, whatever importing is in your language. You could import that code for this get number function into another Rust file, and you could call that function in a place where it is not written. So we'll say call get number, and that can happen here. Let's make that gray as well. Okay, so just remember that when you're working in the same language, you have the ability to directly use code by just more or less importing it across files using the file path. Now, what happens when I have some code in my Rust that I want to be able to call? Typically, if you have a server architecture, like a traditional server architecture, oh, excuse me. So typically, if you have a server architecture, then you're going to want to use, oh, I really do not like the way that looks. Let me find a shape for server. I think that there's like a actual, let's see. Let's use this one right here. So when you have like a server architecture, and let's say this is like a Rust server, then typically you would do a request. And we'll say this is an API request. And for us, we typically are using REST. Okay, so this is typical for a server. And what this means for our code is that if we're using a server to communicate, then that means that we are depending on some very specific syntax that will allow us to communicate regardless of what code is running between the two parts of our infrastructure. Because this request here, API means application programming interface. What that means is that we have a system of messaging. And in this messaging system, we have the ability to basically say, hey, I'm going to do a GET request to the server. And in this GET request, I want the server to have whatever information. And the server would be responsible for knowing what to do when that GET request happens. So this is an indirect way to manipulate and control whatever this Rust code is designed to do using an API. Now, what makes Tauri different in this sense is that we're not going to be relying on an API per se. With Tauri, we're going to be relying on invocation, which is a slightly different approach. Invocation works because we have a bridge that allows us to run code between two or more languages. So this API request is the typical way, but we're going to be using an alternative strategy. Let's go ahead and put an X through that API approach here. And let's make that a chunky line. Okay, so what we're going to be doing here instead is we're going to be using invocation. And invocation, what that basically means is that we will call a function that will call a function on our behalf, essentially. So I don't know what's a good shape for invocation. Let's use, no, that's too similar to what we already have. Let's use, I don't know, let's use this right here. Okay, so invocation is a slightly different approach. Let's make that black and let's make the text here white. So with invocation in Tauri, which is what we're going to be talking about here, what we're essentially doing is we're saying, hey, there is a specific package that Tauri has written that we can leverage. And if we give it a keyword or a key term, it will call the corresponding Tauri code that's been registered for that specific command. And it allows our JavaScript to do that so that it can leverage whatever is happening in Tauri and potentially even receive messages. Now, this is similar to API requests in the sense that there is something outgoing and there's something incoming. So just to make the comparison, with APIs, we have a request and we also have a response. And we have that same thing happening with Tauri invocation as well, okay? So we're gonna be able to make a request like, hey, can you do this thing for me? And it will give us a response. And in either situation, they need to be deserialized or turned into a format that can be used in whatever the receiving language is. For JavaScript, it'll be JSON, very likely. Okay, so hopefully this isn't too difficult to understand. We'll revisit this if we need to in the future. But just know that this bridging, this can happen with any language. And it's just a different strategy, and it works really well when you have things that are more tightly coupled, such as desktop application infrastructure. Okay, so yeah, take that for what it is, and let's go back here. Okay, so you can see here that we have in our code, excuse me, inside of our lib.rs, we have a command here. So we've registered a command, and this command is for the greeting, okay? So whenever this command gets executed, it is going to return, oh, excuse me, I'm struggling here. Whenever this command here is executed, meaning that whenever our JavaScript does something that specifically calls this command, it's going to return this formatted string where we have an incoming name, which is being held in a pointer in memory, and that name is going to be injected in this position here in order to create a formatted message. And that's why we're able to see this here. Okay, so if we go to our corresponding code in our front end, we can see what that's doing. So we'll go to source, and then we'll go to app.tsx, and we'll open it here on the bottom so we can look at them at the same time. So the first thing that's happening inside of this app.jsx, let me make my face a little smaller. So the first thing that's happening inside of this app.jsx here is that we are importing the invoke function from our Tauri core. Okay, so this is what we need to be able to call something that is described in our Rust code. Think of this as a bridge, okay? So this sends a message to the back end. So if we go down here, we can see that it is an asynchronous function because it's essentially our server. It is our server. So we need to make sure that we asynchronously call it in the event that it fails, okay? So we call invoke, and when we call invoke, we give it the name of the thing we want it to actually call for us, which is the name of our function, which has been registered here. So we call greet, and this greet function is expecting an argument called name, which we will define here, which is name. Now in this code here, our name is being held in a signal because it is a part of the component state. So the user would have entered this in through the form here, and then we're just simply injecting it into this property of this object, and then it's being used in this Tauri function. Okay, so this is how we're using the front end through asynchronous calling of this invoke function to communicate with the backend. And by the way, this is all being held inside of a signal, and this signal is being used to display whatever is being returned from this Tauri function. So that's why we're able to see this custom formatted string on our DOM right here. Okay. So this is pretty straightforward, but just this this setup here is going to allow us to do a lot of really cool stuff. A lot of super cool stuff. So this invoke function returns a promise that resolves to the value returned by the Rust function. So this is like a secure and efficient bridge between two different worlds. Now, I don't know about you, but I think that this is actually one of the coolest parts of Rust. Or I'm sorry, this to me is one of the coolest parts of working with Tauri, is that we're able to really work with two languages. And the reason why this is really important, in fact, excuse me, is because if you think about what Rust is doing versus JavaScript, Rust is like a very low-level language, and JavaScript is a very high-level language. And with low-level languages, you get a lot of performance, but they are very complicated because you're directly manipulating memory often, right? You're responsible for managing memory, for pointers, also for more nuance in the types, and also it can be a lot more rigid because it is compiled. With high-level languages like JavaScript, you can work really fast. You can make things that are creative. There's a lot of packages, and there's a developer community to support it. There's lots of frameworks. It's just overall a much nicer developer experience for people who want to make things quickly, and typically for nice front-endy type things as well. But there are, such as in our application, going to be a lot of situations where you may want to actually offset some things like, intense calculations. If you're dealing with like vectors and graphics and all sorts of stuff like that, you may actually choose to have some of those things ran by a much more performant language and then just used by the UI to display, right? So in our application, we're going to be trying to offload as much of that really, really intensive computational type of stuff to our Rust backend. And we're going to leave all the logic there as much as possible, and then have our front end as dumb as possible. We're gonna have a dumb front end, so to speak, okay? So that's why this invocation and Tauri commands in general are going to be really important for us, because our server is going to be used for a lot of things. We may even get into some server-side rendering as well, because that could be also a really great way to sort of save on some compute as well as we go. Okay, so yes, so that's that. That is the Tauri invocation. Check out the website to learn more. There's a lot of examples on there, and there are other commands outside of invoke that can be used as well. So this is just the tip of the iceberg. Okay. Let's see here. Make sure there's nothing I'm missing here for now, at least. Okay, so I think that's pretty much it for that. Let's go ahead and move on. We're almost done. We only have a couple more things to do here. Okay, so when you set up your Tauri application, you're going to be primarily using NPM, or I mean, you don't have to use NPM. I'm going to use NPM because that's how I set up my project, but you're going to need to have a tool for actually running the application. Now, you can do this in a variety of ways. I believe that for this type of project, NPM might be the best approach to do this. If you use Bun or NPM or whatever, you know, any of those will work. Yarn. We're using that to handle our scripts though. And this is because we're using Vite. So Vite is an NPM package that we run. Our Tauri command line tools are also NPM installed as well, specific to this project. And so just using a package.json for your dependencies for your project as a whole, and also for your script, is just really convenient. But if you wanted to, I guess you could use like Makefile or something else like that. But there are some essential scripts here that will be set up for you to leverage to actually get your app running. So let's just go through these really quick. So the start command here just basically runs npm vite, and that will basically run the server as it is, and it'll run it so that you can experience it through a web or whatever your web view of preference is. Okay, so that's just for the front end. And this developer script here, this bun run dev, this is what's running our Tauri app as we're looking at it right now. You have the ability to inspect here. There's developer tools that are available. You also will be able to see debugging messages in the console where you run that command, for your server at least. So the development mode is pretty much what you're going to be using. Out of the box, it comes with hot reloading, because the hot reloading is just kind of built into Vite for development mode for Vite, but it's also built into for Tauri as well. When we run this Tauri script here, it is actually going to be leveraging whatever is set up in this Tauri config JSON. So you can see here in development mode, it's going to run the front end server, and it's going to have a URL for that server. Okay, so this is being considered and ran before the actual development command of Tauri is being ran. That's kind of, it's not obvious here, okay? Let's just keep going on. Sorry, my windsurf sometimes wants to display helpful things that are not helpful, so I don't know how to pause that for now, but we'll just keep going. Okay, so this build script here, by the time your application is ready to be deployed, a build script is going to make what's called a dist folder directory. This is the actual transpiled JavaScript that is meant to literally be ran in your web view or your browser, because your browser and web view cannot run, JSX. It can't. It doesn't know what that means. So this build script is mostly going to be used when we're working in a production environment, or when we're just like deploying our application in a way that's meant to be similar to production. Maybe for development, maybe for a sandbox. This is distinct from running it in development where you're actually working on it and making changes. This Tauri script here is going to, this is going to be like the more official way to run your application. So this is going to handle actually building the application versus running it in dev mode. And then we have some formatting. I added these here. I'm big on formatting. Our application actually has like a lot of documentation in it, so I thought it made sense to have not only prettier, but also a linter for Markdown. And we'll add some more in here. I'll probably make this linting these linting and formatting things to be compounded across different types of files, not just Markdown. But that's just where we are right now. So npm run dev here. The main thing is that this is what we're using to run our application in developer mode, where we can make changes. And then npm run build, this is going to, or Tauri build, that's going to allow us to make the distribution, create a distributable application that will bundle everything into a native installer for either Windows, Mac, or Linux. I think 2.0 for Tauri can also do mobile. Okay, so we need that build in order to actually make the final thing. So Tauri has its own CLI commands, and you can go to their website to learn about their CLI commands. The CLI for Tauri for our project is installed as a developer dependency in this specific project, but I believe you can also install it as a global thing. I would just prefer personally to leave it inside the application as opposed to making it global though. It's much easier to handle, like, updates and stuff and versions and stuff like that. But here's all the commands you can use. So the build one here, we don't actually have a build one in our code right now, but we can add one. There you go, boom. Okay, so use that website to learn about what the different commands are. There's commands specific to running and building the application for different targeted environments and operating systems and stuff. I don't know anything about that right now, but we will get to that, soon enough. Okay, so let's talk about some key takeaways. So the big things to think about here are that with Tauri, we get the advantage of having an actual application where the front end is agnostic to the back end. So we could use JavaScript, but also we could use other things. As you saw at the beginning of this video, we could easily replace this front end with C#. We could do Golang front end. We could do a front end that is Dioxys, which is Rust. We could do any type of front end we want. The main thing is that Tauri allows us to use invocation, which is a bridge that allows us to call Rust code from any other code that we might be using from our front end. And it doesn't matter what that code or that language is. So we're really thinking about two halves, and they're being packaged as a whole. So think of Tauri as having two distinct parts: a web-based front end for the UI and a Rust-based backend for the core logic. Even though it says web-based, Tauri can work with non-web-based UI. It can. It may not be like the most optimal way, but it could. The front end doesn't actually matter. As long as you're invoking and as long as that front end is able to run. It may not necessarily be packaged as well though, because Tauri is designed for web-based front ends. So the front end and the back end are important. The back end for Tauri will likely always be Rust, although I think that they may be working on some other ways to use the back end. I don't know much about that, but it was alluded to in the podcast that I shared with you. The other thing to take away from this is that there are two main folders where you're going to be working. So you'll be working in the source folder for your front end and source Tauri for your back end. Okay. And then the next thing here is that you have these commands. Tauri commands are really the magic that allow you to communicate between the front end and the back end. So if you can see here, we have a function that calls the command to invoke this function called greet. Okay, so this asynchronous function to invoke greet passes an argument called name, which is coming from our signal that stores the name the user gives in this form right here. And then the command is being bridged by this invoke function, which is defined in our Tauri code right here in our lib.rs. And these are registered so that anything that can invoke can have access to them. The registration for the function is this part on line number 2. Okay, so this is what makes it a command that's accessible. So that's how we can so essentially use 2 different languages and have them work in a way that feels rather seamless. And then the last part to take away is that we have this Tauri config file. So this is essentially the control panel for the entire application. So in this file, it's kind of similar to some things that you might see in like a Vite file. So here we have version, name, all that kind of stuff. We have some details about what it means to build. We can call the build script in our code, but we give it more nuance for like what needs to happen in that build process here. We can also define some features of our app, such as the size of the windows, the name of the app in the window, that kind of stuff. And so pretty much anything that's related to the application configuration is going to be here. And then the last thing, I guess, is that we have icons as well. When you have an application, there is an icon that will be displayed on, for the actual application on the desktop of a person's computer. And you can control that as well. In the configuration, you can set that right here. Okay. So these are all the things that I think are important to know. Do your own research, and most importantly, play around. The Get Started guide for Tauri is very easy to follow. It won't take you very long to get to the point where I am. What you're looking at here is literally just like the default template application for SolidJS with Tauri, with Vite, of course. And if you follow the guide here, it will get you that far. Okay, so just go to Tauri or v2tauri.app/start and just follow this guide here. And if you need a little bit of extra help, feel free to use the link in the description of this video, which will take you to the actual document that I've been using to guide this stream, which is our Tauri guide. The link is in the description below. Okay, so that pretty much wraps up this stream. I want to thank you for joining us today. And yeah, if you like this video, if you like this stream, go ahead and leave a comment down below. Let me know which part stood out to you the most. If you have questions, I would love to hear from you. My name is Key. I am the founder and the lead engineer of Primatif. And yeah, I'll be making more videos about this. Come back on Monday or Tuesday, and we'll be doing the next stream where we'll be basically jumping back into the building part of this project. I have pretty much the whole project laid out in a scope document. So when we come back on Tuesday for the next stream, I'll just be continuing with our sprint here. And let me just take a look and see what we're going to be working on. So when we get back on Tuesday, we're going to be working on setting up the server. The server, as well as the excuse me. We're going to be setting up the server to use the database, which is SQLite, to essentially hold and retrieve some information to display on our DOM, which is a part of our prototype, for getting this app to the next level. Okay, so that's going to be on the next stream. So stay tuned. Don't forget to like, comment, and subscribe, and then hit the bell notification if you want to get updates on when the next streams are. And that's pretty much it. So thank you for coming by. My name is Gay, And I think I've said this before, but I do like the world's longest Minnesota goodbye. If you don't know what a Minnesota goodbye is, basically it's like you're trying to leave. We're like, you know, peace out, see you later, homie. And then we start talking again, and then it just keeps going, and it gets worse and worse and worse. And the next thing you know, our goodbye has been an hour. It might even be longer than our actual conversation. But I'm not gonna suffer you through all of that. So I'm just gonna get off. So bye. See ya. Oh, by the way, if you enjoyed the music at the beginning of the stream, that is some music that's original for our channel and our page. And I'm going to play a track called Dopamine. So please enjoy this on your way out, and I'll see you next time.
It's the breakdown. Release that. Release that.